Right. Okay. Okay. Then questions. So where did we stop last day? Last day, I think we have done some questions, and so we have pending. And 2000, 2002 available question number 5. 2002 available question number 5. 2002 available question number 5. Now every MCQ, every question we can learn something new, right? So by learning, by doing every question, we are learning something new. That is most important thing. Read the question. Read the question. Someone share the pasted PDF in the groups. If you read the question, non-viscous incompressible fluid of density rho flows through pipe at a speed of simple V. 2 manometers capital A and capital B. 2 manometers capital A and capital B are connected to the pipe as shown in the figure. If the pressure measured by manometer capital A and manometer capital B are P1 and P2 respectively. If the pressure measured by manometer capital A and manometer capital B are P1 P2 respectively, the speed V of the flow is given by. Now, in hydrostatics, we learned that manometers are used to measure the pressure. Okay. I just do the rough diagram. If I do the rough diagram, right. But even though this diagram seems like very complex diagram, but it's the idea is very simple. The idea is very simple. The idea is very simple. Right. Non-viscous incompressible fluid of density rho flowing through a pipe at a speed of V. Now there's a fluid. We don't know whether it's a liquid or gas. We have no idea. Maybe it can be a gas, but it can be a liquid. Doesn't matter. They commonly mentioned as fluid. Let's assume it as a gas or something. And then that gas is flowing to the right side direction with a velocity of V. Okay. That gas is flowing to the right side direction with a velocity of V. And in the question, they mentioned that if the pressure measured by manometer A and manometer B are P1, P2 respectively, the speed V of the flow is given by. Now, given data P1, P2, pressure measured by manometer A and manometer B, and density of the fluid, density of the gas, that is given as how much? That is given as rho. Now, we want to find the speed of this given fluid in terms of target is finding this given state in terms of, we want to find this V in terms of density of this fluid, rho, pressure the manometer P1 and pressure measured by the manometer P2. Okay, pressure measured by the manometer B and pressure measured by the manometer A. That's our target, right? Okay. Then normally we know these scenarios whenever there is a fluid undergoes a motion that is linked with the fluid dynamics theory concepts. And when it comes to fluid dynamics theories, there are two main theories. One is the Bernoulli's equation, other one is what? Continuity equation. So this is what we apply for all the scenarios. The very scenario also very clear, it's a fluid dynamic question. And anyhow, we want to apply Bernoulli's equation. In cases, we might have to apply continuity equation A1 V1 equals to V2. Right. So when you are applying the Bernoulli's equation, the first story is you want to consider you want to select a streamline. Now I'm selecting a streamline. Look at my streamline. So now you can, there are infinite amount of streamlines in the fluid flow, but you can select whatever the streamline that you prefer. But I am selecting a streamline. Passing at the bottom of the tube, and that streamline is passing through this this small tube as well. So this tube is a part of manometer B. This tube is a part of manometer B. And I'm going to consider two different points of the streamline. Sometimes I maybe before I explain the story, you might have no idea how to solve this question. But after I explain that, remember, this is what they are going to ask in different formats in your A-level exam. Therefore, once I explain the story, what you do, right? Thereafter, remember, this is how you will solve. If there is something asked in this way, this is what you will do. Right? Every question, just imagine you are learning a theory. Every question, we learn a theory. Think in that way. I'm going to consider 2 points on the streamline. So one point is point capital A, other one is point capital B. Just think that point capital A is closer to the manometer A and point capital B is closer to the manometer B. Right? Manometer B. The highlighted, the most important stories. Sometimes we don't even feel that story. The most important story is, remember, when the gas, what will happen? Just imagine practically, there's a gas flowing through a tube, and what would happen when the gas starts to flow through a very narrow, very tiny tube? What happens is, remember, velocity of the gas, velocity of the fluid, because what's happening when the gas passes through this narrow tube, that fluid traps inside the tube. So when the fluid traps inside the tube, remember what will happen? Its velocity reduces and its velocity becomes zero. So this is the point that we won't remember, or that we won't understand. Remember, when a fluid passes through initially it passed through a large tube, and once a portion of that fluid enters to a very small narrow tube, remember, its velocity becomes zero. So this is the important point in this question. Remaining story, you can do it. So velocity of the fluid at this point, capital B, is going to be zero. That is the important story that you don't remember. Then velocity of the fluid at point capital is going to be V. That is going to be V. That story we know. And remember, pressure at point capital A and pressure at point capital B are going to be P1, P2. Pressure at point capital A is P1, pressure at point capital B is P2. Then that's it. Velocity we know. So what we can do, we can consider point capital A and point capital B. Just you want to apply the Bernoulli's equation. Just you want to apply the Bernoulli's equation. So that this idea is the different idea. Sometimes you don't remember this idea. You don't get this idea actually. Even when I was doing this in my this is what year? Yeah, I have done when I was doing my LS also. It's 2012, yeah, right. So when I was doing this also in my first time, I told you my story because I am not that much a bright student. I was a very average student, right? So when I was trying this question also, I had no idea. I have done plenty of Bernoulli's questions. I have done plenty of past paper questions, but when I were doing this question, actually I got stuck. And once I reviewing the reviews, once I referring the reviews, and only I realized there's something like this. So therefore, doesn't matter every question. Learn a theory, then that's it. So 4 point capital A and B, I'm applying Bernoulli. 4 point capital A and B. If you apply Bernoulli, 4 point capital A and point capital B. So then story finished. Bernoulli's equation is, we all know that if you apply Bernoulli's equation for two different points, that's going to be P1 plus half rho V1 square plus rho GH1 must be equal to P2 plus half rho V2 square plus rho g h2. Rho g h2. This is our Bernoulli's equation. This is our Bernoulli's equation. And when you consider point capital A and point capital B, they are on the same horizontal level. Let's assume this level, this horizontal line has a zero potential level. So then we all know that rho GH1, potential energy per unit volume terms become zero. Potential energy per unit volume terms become zero. Then remains pressure at point capital A, that is going to be P1. That's going to be P1. And plus velocity of the fluid at point capital A going to be V half rho. I want to find this V only, half rho V square. Half rho V square must be equal to pressure at point capital B going to be P2 plus we know, as I explained, velocity at point capital B going to be 0. So therefore then half rho V2 square term also going to be 0. That's it. So this term is 0. The difficult to think is this idea V0. Then when you substitute V, we will get the answer. We substitute V, we will get the answer. Then your V going to be how much? If I move this P1 to the right side, then P2 minus P1. Then P2 minus P1. P2 minus P1. Right, if you subject V, P2 minus P1, I think 2. P2 minus P1 over density is rho. And the whole root is the answer. This is the answer. This question. Learn something from every question. Learn something from every question. Now we are starting that paper writing stories also for 26 batch also from this week onwards. So then I think that you are getting a super experience of writing papers and discussing questions and doing questions. Then only target is consistently, continuously doing that. Okay. So the next question. Next question. Right. So then what else I could not discuss? I did question number 11. 2009 A-level question number 11. 2009 A-level question number 11. Question number 11. Idea. A non-viscous fluid of density simple D has a streamlined flow through horizontal pipe of variable cross section as shown in the figure. If the pressure of the fluid is capital P at the point where the velocity of flow is V, what is the pressure at the another point where the velocity of the flow is 3V? Now they are telling pressure is capital P when the velocity is V. They are asking what will be the pressure when the velocity is 3V. Story. The story. Nice story. Now I think we can do these type of questions are not difficult for us since we have a good exposure. Right? We have done past paper essay questions. Right? Okay. Again, same story. There's a fluid. That fluid is flowing maybe to the left, the right. Always I consider streamline. I'm going to consider horizontal streamline. Is my horizontal streamline. So then let's consider 2 points. This point is point capital A. Point capital A is at the lowest cross sectional area of the tube, and point capital B going to be at the largest cross sectional area of the tube. Point capital B is at the largest cross sectional area of the tube. Right, okay? Okay. Now already we know that from the continuity equation, A1 V1 equals A to V2. If not that concept, continuity equation says what? Volume flow rate, mass flow rate is constant ideally. When the density of the fluid remains constant throughout the flow, then the volume flow rate is constant. When the volume flow rate is constant, we know that volume flow rate is what we identified last week. Also, same thing explained. Volume flow rate means we know that cross-sectional area into velocity, right? Volume flow rate means we all know that cross-sectional area into velocity. When the volume flow rate constant, when cross-sectional area increases, we know that velocity of the fluid should decrease. When the cross-sectional area increases, the velocity should decrease. That's the idea. Very clear. A to B, cross-sectional area increases. A to B, velocity should be decreased. Velocity should be decreased. A to B. Smaller cross-section should have larger velocity. Larger cross-section should have smaller velocity. Since this is the smaller cross-section, its velocity must be larger. They have given velocities as V and 3V. Then 3V belongs to point capital E. 3V belongs to point capital E. 3V. 3V belongs to point capital E. Is 3V velocity. And actually, they ask in the question the pressure corresponding to 3V velocity. I say the pressure corresponding to point capital E. That is, let's say P. Let's say that is P1 something, P1. My target is finding P1. Then cross-sectional area larger means velocity of the fluid at point capital B going to be lesser. That velocity they have given as capital V. The velocity given as capital V. The velocity given as capital V. And the pressure corresponding to point capital B, that is given as capital P. And we want to find P1 in terms of given data, maybe V and P. Maybe V and P. I want to find P1 in terms of maybe P and V. P and V, that's my target. So what we can do here, what we can do here we can do, I think everything is correct. So we can apply same story, we can apply Bernoulli's equation. Bernoulli, if we apply Bernoulli's story, Bernoulli, right? Bernoulli's story, Bernoulli's story. P1 plus half rho V1 square plus rho GH1. Rho GH1 must be equal to P2 plus half rho V2 squared plus rho GH2. Same story since point capital A and point capital B are the same horizontal level. If you consider this streamline, horizontal line as zero potential level, this horizontal line as zero potential level, then we can say that a gravitational potential is equivalent volume terms become zero. Rho GH1 and rho GH2 becomes zero. The story, you know why. Okay. Right. Okay. Then thereafter direct substitution. P1. My target is finding P1. My target is finding P1 plus density of the fluid they have given us D. Density of the fluid is simple D. Velocity at point capital A is 3V. 3V square means we all know that's 9V square must be equal to pressure at point capital B is going to be capital P. Density of the fluid is D half D. Velocity of the fluid at point capital B is going to be V squared. V squared. Then target is finding P1. So therefore, what we can do here, if we substitute P1, we will get the answer. Subject P1, we will get the answer. P1 going to be capital P. I want to move this half the 9V1 square term to the right. Okay, then minus. Okay, minus. Okay, P1 plus half dV squared. Half dV squared minus 9 over 2 dV square. Now very simple. Then Then here, if you take half dV square as your common factor out, if you simplify this, you will end up with here 1 minus 9 means minus 8. Minus 8 over 2 means minus 4. I think answer is pretty much obvious. Minus 4 dV square is our answer. Are there any answer? capital P minus 4 dv square. Capital P1 equals capital P minus 4 dv square. Any answer? That's an answer. Answer is 2. This answer is 2. Answer is 2. If I have done a mistake, please tell me. Next story. Next story. A 12th one. Now 12th one. Now upcoming days. Now as I told you, right? From unit 3 onwards, even I discuss past paper, section wise MCQ, essay, structure discussion. Normally, past paper discussions are I'm doing as section wise discussions. They are section wise discussions. Definitely till your IL exam, all the past paper discussions are going to be section wise discussions. Likewise, MCQ. If I've completed MCQ, then essay, then structure essay. Right now, from unit 3 onwards, you should do these questions before. But already I will tell you this Wednesday I'm going to discuss these MCQ sections only. Then you can practice and you can come. Okay. So then I think you get a good exposure than this. Now here I know that most of you haven't tried these questions yet, right? Hands up who have tried all the fluid dynamics questions so far. So I have tried all the fluid dynamics questions. Hands up. I have done all the past paper since we are finished doing unit 2. Actually, I have tried all the past paper MCQs. Hands up. Hands up. Right. There may be 1, 2, but I know majority are not like that. I know, right? But ne should do, but at least ne should do. It's okay. 2009. Anyways, even you have done these questions also when you just join for the sessions, and when you just stay in the session, then you can revise the stories, and I think you get something. Yeah, you get something, right? During the discussion, definitely you will get something. 2009 A-level story. Question number 12. 2009 A-level. Question number 12. Non-viscous incompressible fluid steadily flow through the pipe shown in the figure. The variation of the flow speed V of the fluid along the tube from A to F is best represented by. Now I'm not going to draw that diagram, but I will summarize some stories. So from this story also, it's very obvious that large the cross section, when the cross sectional area of the fluid flow increases, the corresponding velocity decreases. You'll agree? When the cross sectional area increases, we learn that velocity of that fluid flow should decrease. Is the idea. Now just consider A to B cross section and just consider A to B cross section. A to B cross section. When you compare with A to B cross section, with other cross sections in that tube, A to F, be very clear, A to B cross section going to be the smallest cross section, A to B. And just compare B to C, C to D, D to B cross section. Just compare just B to C, C to D, and D to B cross sections. Raise your hands, how many we say? B to C, C to D, D to E cross sections are same, equal, and when you look at the diagram, how many we see? B to C, C to D, D to E cross sections are same, sir. They are same. They look like they're same. They are same. When you compare B to C, C to D, D to E, if not directly I'm considering B to E cross section. B to E cross section, when you compare the pipe from B to E, the entire cross section, and when you compare with A to B cross section, obviously very clear, A to B cross section is smaller, B to B cross section is larger. And when you compare A to B cross section, B to B cross section, E to F cross section, E to F cross section going to be the largest. Then very clear, A to F, we notice that cross-sectional area increases. A to F, we notice that cross-sectional area increases. That means it's obvious. Velocity should decrease A to F. Velocity should decrease A to F. A to B is the largest velocity of the fluid. Fluid obtains large velocity at A to B region. A B to C bit lesser. Sorry, B to F. Sorry, B to E bit lesser. B to E bit lesser. E to F the least, lowest. What's the right answer? Tell me. Satisfying those conditions, the right answer must be what? What do you say? What should be the right answer? Reply. The right answer must be fourth one. Right answer must be fourth one. Right answer must be fourth one. Okay. Right answer must be fourth one. Fourth one. Then 25 people. Tomorrow we are doing that one essay and remaining for stock essay discussion. Tomorrow 10 p.m. onwards. Tomorrow we are writing the next MCQ paper. And then Friday we are doing that discussion definitely. Saturday night, Sunday night, we are having that past paper discussion. So today I want to do a past paper discussion for 25 batch, but still I'm preparing that tomorrow's paper. So therefore, sometimes I won't do the class 10 p.m. to 12, but preparing the paper. Then Friday, Saturday, Sunday. Saturday, Sunday we have 2-3 classes, and we'll do like that. Okay, right. Next story. Next story, I think question number 13 I discussed, 14 I will discuss, 2012 level, 2012 level 14. This idea. 2012 level. Question number 14, idea. A large metal sheet bent into the shape shown in the figure is kept upright on the ground by means of 4 stretched ropes fixed to the ground. No, very simple. There is a metal sheet. Metal sheet, if not, you can take your yeah, metal sheet. It's kind of a metal sheet, very large metal sheet, like a whiteboard. There is whiteboard. This is a kind of sheet. Now you place that whiteboard vertically with the help of 4 ropes. That whiteboard is you connected 4 ropes, and with the balance of those 4 ropes only, this whiteboard remains vertically stationary. Thing like that. Thing like that. Can you imagine? There's a whiteboard and there are 4 ropes tied to the whiteboard in 4 sides, like this. Can you imagine? Look at the diagram also. Diagram also. Right? So what they are coming to say? By means of 4 stretched ropes fixed to the ground. Magnitude of the tensions in all ropes TA, TB, TC and TD in the still air are equal. The still air are equal. When the wind blows through the sheet, in the direction XY, in the direction XY, in the direction XY, direction XY, when the wind blows through the sheet in the direction XY, in the direction XY. Look at this idea. I'm not drawing the same diagram, but I try to draw a kind of simplified diagram. Okay. When you look from the top, I'm going to draw the way how that sheet appears when you're looking from the top. This is your sheet. Top view. The sheet. The sheet. And there are 4 ropes tied to this sheet. There are 4 ropes. 1, 2, 3, 4. If I name those 4 ropes, rope A and rope D in this side, as per my understanding. If I'm wrong, tell me. Rope A and rope D must be in this side, and then the rope B and C. Rope B and C. A and B, C. Rope B and C. Rope B and C. If you can't hear me speaking, please tell me. Row B and C. The diagram is not clear. Row B and C, right. Here is our row B and C. This is A and D. This should be A and D. This should be B and C. A and D, this should be B and C. All right. Okay. Now they mentioned, then just tell me what should be the direction of tension forces acting on rope A, B, C, D. Now, if there is no any wind blowing across the sheet, if there is no wind, if there is a still condition, then we know tension. The tension force acting on the sheet due to the rope P. This is T. Okay, this is T. The tension acting on rope D going to be TED. The tension force acting on rope B going to be TB. Because you maintain this sheet stationary with the tension forces acting on the sheet, right? Then TC, right? Okay. So when the air is at still condition, they mentioned all the four ropes have same tension, because that's obvious, right? That's obvious. The reason is your sheet is in the vertical equilibrium. The sheet is in the vertical equilibrium. Then there are what? Now two ropes to the right side of the sheet, and there are two ropes to the left side of the sheet. Then we can say that if there isn't any air flow, we can say that tensions are same. It is the same, because there is no point for the tensions to vary. But when the air blows from only one side, when the air is blowing in one side, now they mention, as per my understanding, when I look at the diagram, I understand that air is blowing in the BC rope side. If I'm wrong, tell me. Air is blowing in the BC rope side. Air is blowing this side. Then look at the diagram. They have mentioned that this sheet has bent in this way. The sheet has bent in this way. Earlier sheet was actually a straight sheet, but due to the air blowing from BC side, we noticed that sheet has been this way. It seemed like sheet has been this way. Sheet has been this way. Right? Then what you can say? Okay? But air is blowing, but we don't know. I think I mentioned air is blowing in BC side, but somehow look at the bending direction. We can say that the sheet has been this way. Sheet has been towards BC rope side. Sheet has been towards BC rope side. That is very clear. Now air is blowing. Then what happens? Due to the shape of the sheet, we notice that they are streamlines. In the BC side. The gap between adjacent air streamlines passing in the BC side becomes less. The gap is going to be less. When the gap between the air streamlines going to be less, then we know that velocity of the air streamlines in this side, in BC side, going to be larger. Velocity, I mark this point as let's say point N, point capital N something. So velocity at point capital N going to be larger velocity. Let's say point number 1 is point number 1. Velocity at point number 1, because of the shape of the sheet. I am drawing the top view. Imagine the top view. If you are a crow, right? If you are when you are flying in the sky, you are a crow. When you look the sheet would appear a straight line if there is no any air blowing across the sheet. When there is air blowing to the sheet, you notice that sheet has bent this direction. Sheet has bent towards BC rope side. That case, because the shape of the sheet, the air streamlines in the BC side come close to each other, resulting in a larger velocity of the air streamlines. Velocity is larger. So V1 velocity, the pressure corresponding to this side is P1. So then, but when you consider this side, velocity, this side velocity going to be V2 velocity. I consider a point here. This point is point number 2. Point number 2 velocity going to be same as V2. Pressure corresponding to point number 2 going to be P2. We know that larger velocity means We all know large velocity means smaller pressure. So V1 is larger. Since V1 is larger than V2, large velocity means we know smaller pressure. That is the Bernoulli's idea. Bernoulli's idea says when the velocity is larger, pressure is smaller. The pressure is smaller than P2. See, P2 pressure. P2 pressure is larger. We notice P1 pressure is lesser. That's it. If the P2 pressure is larger, if the P1 pressure is lesser, very simple now. Now they ask me us to find the compression of tension forces now. Before, when the air is at still condition, we notice that. When the air is at still condition, we notice that all the ropes have same tension force. But here, when the air flows across the sheet, we notice this region creates a larger pressure. There's a larger pressure acting on the sheet. There's a larger pressure acting on the sheet in this side. Pressure acting on the sheet in this side is lesser. So you know this story. Just consider an area. Just consider an area. Take this as your plate something. And this plate is connected to a rope. Tension acting on the rope is capital T. Now what you are doing, you are applying a larger force on the plate. So when you apply by using your hand, there's a rope, or it can be a door, or it can be something in the vertical direction, something hanged or whatever. So when you apply a larger force, you are applying basically larger pressure. So more the force, more the pressure you apply on this vertical plate, what will happen to the tension force? Tell me. Raise your hands. More the force I apply to the plate, sir, the tension force increases. The tension force should increase and up. The tension force should increase. So if I apply larger force on the plate, as I'm understanding, tension force acting on the rope must be increased and up. Must be increasing. Definitely, obviously, tension increases. We can feel that. Same story. In this side, see if I do this diagram again here. If I do this diagram again here, but I erase it. We noticed pressure P2 is larger and pressure P1 is lesser. We know due to a pressure, the resultant pressure force always acting perpendicular to the contact surface. Remember, the most important story is in pressure, due to a pressure acting on an area, the pressure force always perpendicular to that area, acting towards the area. Remember, the pressure force generated due to a pressure acting on an area is always perpendicular to the area, always towards the area, always towards the area. Most important point. Then if I just mark the resultant pressure force due to the P2 pressure, the resultant pressure force due to the P2 pressure, it's just going to be, let's say, F2 something, F2, perpendicular to the plate, towards the plate. Because since P2 is larger, you want to understand F2 is larger. Since P1 is smaller pressure, the resultant pressure force acting on this sheet due to the P1 pressure is perpendicular to the plate, toward the plate, smaller. That is F1. Then if I mark the if I mark, look here, these for ropes. If I mark for ropes, this is larger force. Anyone can tell that then the tension TA and tension TD must be larger, right? Since this force is lesser. Tension TB and tension TC must be smaller. Am I correct? Right? If you apply larger force in this side, these two strings stretch more. These two strings tension more. Therefore, TA TD larger, TB TC lesser. Answer this idea is clear answer. This idea. What is the answer? Idea is clear answer. The story explained is very clear answer. The story explained is clear. Then what should be the answer? What should be the answer? What should be the answer then? Reply. What should be the answer? Reply. Answer must be what? Go tell me what the answer. Answer must be then the comparison between A and B, D and C. A and B, D and C. Then we know that T is larger than TB, TB is larger than TC. What is the answer? Tell me what is the answer? What is the answer? Someone tell me. What should be the answer? The answer must be, I think second one. Second one, story. Okay, nice question. Nice question. But you also imagine, you also think, right? After I finish the class, it doesn't matter what is your level. It doesn't matter you are going to take island first also. I don't mind. Once again, redo it. Once again, redo it. Once again, redo it. That is really going to give a benefit for you. Okay, and that's also discussed in next one 14 done. Discussed 15 story 15. I am not going to discuss question number 17. 17 is all. 17, there's a small issue in the question, therefore I am not discussing 17. 17 is all. So they have given due to a small issue because the diagram issue, but I am not discussing that. 17 all. In that year they have given all for that question. So today we'll complete circular motion story also. 17 all. 2016 level. 2016 A level. uh, 17 all. Then 15 2013 A level. 2013 A level 15. 2013 A level 15. Right. I think I should draw the diagram. I think I should draw the diagram. A cylindrical tank having a very large diameter contains two immiscible liquids of densities D1 and D2. D1 is greater than D2, right? The tank has a small hole closer to the bottom. See the figure. If the heights of the liquids at a certain instant are H1 and H2, what will be the speed capital V of the liquid ejecting out the tank at the instant? Neglect the surface tension effects and assume that the liquid are non-viscous. Now, since they mentioned, when you consider tank, since they have mentioned that tank has a larger diameter, when you consider free liquid surface of the topmost liquid is larger. So in fluid dynamics, we are doing an assumption. If the liquid surface, when liquid undergoes, if a liquid is flowing, and when you consider a certain, when you consider the top surface of the liquid, if the liquid's cross section is larger, we can say that velocity is very smaller. The velocity very smaller means we can assume that velocity is approximately equal to zero. Based on that, we can do the question. Now we have to do that assumption in this MCQ also. I do the diagram. I do the diagram H1, H2 story. H1, H2 story. This side is H1. This is going to be H2. Right. Then we understand that density of this liquid, there are two immiscible liquids. They do not mix with each other. That's why we call it as immiscible. This liquid density is D1. This liquid density is D2. Right. And there's a small hole at the bottom. Liquid is ejecting through this hole to the outside. Liquid is ejecting through this hole to the outside. 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 Have they given the diameter of that small hole? Have they given the diameter of that small hole? Height of the liquid served instant H1, H2. What will be the speed V of the liquid ejecting out tank? Right, okay. No need. Right, okay. There are two different fluids. Listen very carefully. Decide very carefully. Listen. Now, always now, if this is a fluid dynamics question, same story. We want to apply Bernoulli's equation. If not, some cases we want to apply continuity equation. But anyways, when you're applying Bernoulli's equation, means first of all, you should find a streamline, a suitable streamline, and the most important thing is you should select two suitable points on that streamline. And then only you want to apply Bernoulli's equation for those 2 points. Now again, my streamline going to be because the fluid is coming from here and the fluid particles are leaving to this hole. All the fluid particles are leaving to this hole, right? So if you draw the streamlines, you know how to streamline this case. All the streamlines should draw like this. If I draw one streamline, is a streamline. So the 2 points going to be most of the times, since they talk anything about this top surface, first point going to be the point on the top surface of the fluid. Other point going to be at the nearby the hole. Other point is going to be at the hole. That is point capital B. Point capital B. We want to find expression for the velocity of the fluid ejecting from point capital B for the hole. This is my target V. Given data, I want to find V in terms of given data, maybe H1, H2, D1, D2, D1, D2. Gravitational acceleration maybe G. That's my target. That's my target. Right, okay. 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 Right. How can I do this one? How can I do this one? Not difficult. Not difficult. Same story. I consider the bottom level as my zero potential level. Bottom level as my zero potential level. Then AC. Bottom level going to be my zero potential level. Is at PL. If I apply Bernoulli again, Bernoulli for point capital A and point capital B. Then P1 plus half rho V1 square plus rho GH1 must be equal to P2 plus half rho V2 squared plus rho GH2 idea. Same story. All the questions is what we are doing actually. Right, okay. Then this is my point 1 going to be point A, point 2 going to be my point B. Right. Then pressure at point capital A, we know that when you consider the fluid particles at the top free liquid surface, they are open to atmosphere. So therefore, in the theory class also I explained that in that case, pressure at point capital A going to be equal to the atmospheric pressure. Very important point. Pressure at point capital A going to be the atmospheric pressure. Pressure at point capital A going to be the atmospheric pressure. And also, since the fluid particles at point capital B open to atmosphere, we consider pressure at point capital B also at the atmospheric pressure. Right? Then pi, P1 is my pi, P1 is pi. Then half rho V1 squared. Since the velocity of the fluid particles at point capital is 0, since the velocity is 0, half rho V1 squared term going to be 0 plus rho, not rho, plus, look here, rho GH1, rho GH1. Right, plus rho GH1. Now my point A, if not the fluid particle at A, that fluid particle belongs to this liquid, right? Density D2. So therefore I can write down rho as D2, rho as D2, rho as D2, rho as D2. Look here. Look here. Okay. Now here is a problem. It's a problem. Okay. Right. Okay. Look here. Look here, small story. Small story. Now, I think this is the very important story. It's very, very important. So, look here. Rho GH1 term. So, some people might be wondering, sir, right? Okay, P1 is equal to the atmospheric pressure. That's okay. Since the velocity of the fluid particle at A is 0, half rho V1 square term is 0. That is also very clear. So, rho GH1 term. Rho GH1 means what? Potential energy per unit volume. Potential energy per unit volume. What is going to be that term? Remember, since there are two liquids involved, the problem is now if there is only one liquid, you can directly tell that if there is only this H2D2 liquid only, then you can tell that rho G rho D2 G H2 as your potential energy unit volume. If there are two liquids, remember potential energy means we know potential energy means it links with the height. So you know what does it mean by fluid dynamics theory? We learned that what does it mean by potential energy per unit volume? Tapu, when you consider the total potential energy, when you divide by the volume, this is what we call as the potential energy per unit volume. So you want to consider the total potential energy at point capital A relative to zero potential level, right? Right. So therefore, what we have to do is you want to consider potential energy per unit volume of this liquid as well as potential energy per unit volume of this liquid height. So therefore, remember, if you want to find the total potential energy per unit volume at point capital A, then you want to consider H1 D1G plus H2 D2G. Hands up this idea clearance. Since we want to find the potential energy per unit volume at point capital A, we want to consider potential energy per unit volume of this liquid as well as liquid answer. That is the idea. I think that is the only difference. Please mark the story. Please highlight the story somewhere else when you are writing the story. When you're writing this, what you do, just highlight and mention why we are doing this term, why we are writing this term. Please highlight, please. H1 D1G, H1 D1G plus H2 D2G. Please highlight why we are doing this. Must be going to be equal to P2 means pressure at point capital B is going to be pi plus half density of this liquid is D2 half D2. I want to find this V squared. I want to find this V squared. Rho GH2. Point capital B is at the zero potential level. Therefore, rho GH2 term going to be 0. This term is 0. Now we'll do a simplification and we'll do a simplification. Now what they ask us to find in the question, we want to find V. We want to find V. We have done something, final answer. We have done something, final answer. Final answer. Then final answer, what we can do here, I can take something like this. What is the answer to this question? Right. Okay. It's a nice question. If you subject V, then you can take G common factor out here. G equals, if you take G common factor out, H1 D1 plus H2 D2 bracket must be equal to D2 over 2 dot V squared. We substitute V finally. When you substitute V, you are getting V as what? 2G H1 D1 plus H2 D2 over D2 whole root. And this D2 is common for H1 D1 term as well as H2 D2 term. Right? This D2 is common for H1 D1 as well as HD2. So what you can do, you can give D2 separately for each term. In that case, we can write down finally. In that case, we can write down finally. Finally, our V going to be, our V going to be V equals, finally our V equals, V equals, uh, V equals, right? Okay. Did you do any mistake? Neglect the surface tension effects and assume that the liquid are non-viscous. Uh, right. Okay. Uh, right. Okay. Hmm. Right. Okay. Right. Give me 1 second. 2G. H1. Give me a second. I H1, H2, D1, D2. No issues. Right. Give me 1 second. What is the mistake? The mistake. Half D1. D1 square. D1. Yes, that's the problem. My bad. Okay. It's D1. Because point capital B is at this liquid. Point capital B is at this liquid. D1. It's not D2, it's D1. That's the problem. D1. Okay. Now, okay. D1, D1. Okay. D1, D1. And then D1. Finally, we get the answer. So you can get this D1 is common for H1, D1 term as well as H2, D2 term. So in that case, what you can do finally, V equals, V going to be equals to 2G inside the bracket H1, D1 over D1. D1, D1 cancel out. Therefore, just H1 plus H2, D2 over D1. D2 over D1, H2 inside the bracket, whole root. Idea. That's a root, huh? Clear. Nice question. Genuinely, hands up. This question number 15 is very clear answer. Once again, redo it. This story is very clear answer. This story is very clear answer. This story is very clear answer. This idea is genuinely very clear answer. It's clear, ne? It's clear. Then next idea. Then I think we how many questions pending in fluid dynamics? I think we finished everything. I think 15 done, 16, 17 is all. Uh, then then what? Then discuss 20. Right. Okay. So then we are going to enter the last stories. 23 seem like easy. 23. 2021 A level. Wind generated by cyclone Burivi, I don't know the word, passed across a region in Sri Lanka with speed of 30 ms minus 1. If the wind had passed over a roof of a house with effective cross-sectional area of 100 meters square, uh, what was the lifting force on the roof due to the wind? What was the lifting force of the roof due to the wind? This wind story, I already explained the stories in the theory classes, right? So, 2021 A level, question number 23. 2021 A level, question number 23. Okay, idea. I draw a house. That's a roof. Now, due to this geometrical shape of the roof, when the wind is blowing above the roof, what will happen? The air streamlines above the roof comes close to each other because of the roof shape. When the air blows above the roof, the air streamlines come together, come closer to each other. As a result, the velocity of the air streamlines above the roof become larger. If I draw some streamlines, you'll understand. If you draw some streamlines, you can understand the story, right? They are streamlines passing just above the roof. See, they are streamlines become, the gap between our streamlines become less. Okay, right. Let's consider the point. I consider streamline. If not, I consider streamline. This streamline, this point I mark it as point capital E. On the same streamline, far from the roof, I draw another point. I mark another point on the same streamline as point capital B. Same streamline, far from the roof, I'm marking another point on the same streamline, that is point capital B. Right, okay. So velocity of the air particles at point capital A going to be V1. Right? Velocity of the air particles at point capital B going to be V2. Also, we'll mark the pressure of the air particles just above the roof. From that point capital A going to be P1. Pressure of the air particles at point capital A going to be P2. Right? And if I draw a streamline just below the roof, right? If I draw a streamline just below the roof. If not, if I take a point just below the roof, remember that point is point C. Whatever the characteristics of the particles reaching at point B has same properties at point C also. If the velocity and pressure at point capital B is V to B2, V to P2, velocity and pressure at point capital C also V to P2. Right? Remember, so when we go far from the roof, we can say that air particles property same as the air particles property just below the roof. This story we learned. Then you can tell that pressure at point capital C is same as P2. Pressure at point, velocity at point capital C is same as V2. This story clear answer. This story. So I considered one streamline. Then I defined velocity at point capital A on the streamline V1, P1. Another point in the same streamline, point B, P2, V2. Since this point capital B is far from the roof, and when you consider a point just below the roof, that point C and this point B should have same properties. Their velocity, pressure, everything must be same. This idea, do you understand this idea? Theory classes, we learn these stories. Hands up, this idea is clear, answer. How many of you understand this idea? Raise your hands if you understand this idea. If you understand this idea, just raise your hands. Can understand this idea? Can you? Can. Right, just refer the recordings also. If you need to watch the recordings, you can go to the theory note also. If the theory note, then you can get this idea. Nice story. Thereafter, very simple. I'm going back to the question. If I go back to the question, the given data, total effective area of the roof is given as 30 meter. Sorry, total effective area of the roof is given as 100 meters squared, and velocity of the air above the roof is given as 30 ms minus 1. Okay, if the wind has passed over a roof of house with effective cross-sectional area of 100 meters squared, what was the lifting force on the roof due to the wind? Right, okay. Okay. Assume that air inside the house was still, assume that the air inside the house was at still condition. Then what is your V2 value? V2 is 0. Yeah, V2 is 0. Yeah, V2 is 0. If the air is at rest, velocity of the air, point C is inside the house. If the air inside the house is at rest, means speed of, if the velocity of the air at point C is going to be 0, then when you consider far point, that is point capital B, then the velocity of the air at point capital B also 0. Right, okay? Now, okay, right. So what can I do? We can apply Bernoulli's equation for the 2 points on the same streamline. So I consider point capital A and point capital B. We know point capital B and point capital C have same properties. I apply Bernoulli's equation for point capital A and point capital B. Bernoulli, remember Bernoulli. For point capital A and B. I think we revised again this entire lesson on sparse discussion. the past discussion, we revise this entire lesson again. So you will 26 paper classes, everything will be very well planned. Okay, right. Then P1 plus half rho V1 square plus rho G H1 must be equal to V2 plus half rho V2 square plus rho G H2. Right. Then P1 pressure at point capital A P1. I have no idea. I just write down it as P1. I have no idea. They haven't given the pressure also. Just write down it's P1 plus half density of the air. Density of the air above and below. You want to consider the same density. They have given density as 1.3. How they given density of the air? They have given it as 1.3. 1.3. Assume that air inside the house was still and the density of air is 1.3. So therefore, air above the roof also you want to consider as 1.3 because they haven't given the data. So we'll assume it's 1.3. 1.3. A velocity of the air at point capital A, that is V1. V1 is given as 30. 30 is squared. Now again, when you consider point capital A and point capital B, obviously point A and B are not at the same level. If you consider now we are applying Borel's equation for point capital A and point capital B, the real scenario, point capital A and point capital B both are not in the same horizontal level. Very clear. It's a kind of significant. There is a small vertical height difference. There's a small vertical difference. But what we do, considering this point B is very far, we are assuming, we are neglecting that vertical height. When I was explaining this story in the theory class, I taught you there is no very anyone can see any point capital A is just about point capital B. So there is a kind of vertical height difference. But what we do, we are assuming since this point capital B is very far from point capital A, we are assuming point capital A and point capital B both are in the same horizontal level. In that case, if you consider this horizontal level as your zero potential level, then the gravitational potential energy per unit volume at point capital B and gravitational potential energy per unit volume at point capital A going to be same. So going to be zero. Going to be 0, 0, 0, 0, 0. Then mass be equal to P2 pressure. Pressure below the pressure at point capital B is P2. P2. Velocity of the air at point capital B is 0. This term also going to be 0. Right? Okay. Then what can I do now? Now, if I move the speed that side, I can write down P2 minus P1 going to be how much? P2 minus P1 going to be half 1.3, that is square. 30 square means 900. 900 over 2 means 450 into 1.3 something. P2 minus P2. Now tell me, which one is larger when you compare P1 and P2? Which one is larger? P1, P2, we know velocity is large at point A. Velocity is small, 0 at point B. Large the velocity, small the pressure. Small the velocity, large the pressure. We know P2 is larger than P1. Obvious. That's obvious. P2 is larger than P1 story. Clear. Then look at this point capital C. Point capital C pressure also P2. Velocity of the air at point C is 0. P2 is larger than P1. Right? P2 is larger, P1 is smaller pressure. So there's a resultant pressure difference acting upward direction. P2 is larger, P1 is smaller. There's a resultant pressure difference in upward direction, creating a resultant pressure force on the roof upward direction. Simple story. Just think if I do this roof separately. Since my target is to explain the theory points from these discussions, look at the roof. If you look at the roof, what is the due to the pressure inside the house P2, there is a resultant pressure force acting on the roof upward direction. There is a resultant due to the pressure inside the roof, inside the home. There is a pressure force, resultant pressure force acting on the roof toward the roof, perpendicular to the roof. That is F2. due to the pressure of the air above the roof. Due to the pressure of the air above the roof, there is a pressure force acting on the roof, toward the roof, perpendicular to the roof. This story explained. Since P2 is larger, P1 is smaller, F1 is smaller, F2 is larger. Then what is the resultant force? What is the resultant pressure force acting on the roof? F2 is larger, F1 is smaller, acting in opposite directions. The resultant pressure force going to be in upward direction. That is F2 minus F1. F2 minus F1. Because of this pressure force only, roof is what we call blown off. I don't know. Okay. Right. Okay. Okay. Right. This pressure, the resultant pressure is acting upward direction. There is a delta P pressure acting upward direction. There is a delta P pressure acting upward direction. This I mark it as delta P. This I mark as delta P. Delta P is equal to something like this. Delta P going to be equal to something like this. Delta P equals 45 to 13. Delta P equals, almost we have done the questions. Delta P equals 45 into 13, 1. And on the next story, the pressure. We know pressure equals perpendicular force, force over area. Pressure equals force over area, that equation. Right? We can remember. Pressure means force over area. Right? The pressure difference acting on the roof is delta P. Then delta P equals the resultant pressure force. But they are asking the question. In the question they are asking, what was the lifting force? Lifting force is the resultant pressure force. Lifting force is the resultant pressure force. The resultant pressure force is the lifting force. F2 minus F1. The lifting force is the resultant pressure force. I say FR. Lifting force. FR. The area is 100 meters squared. The effective area of the roof is 100 meters squared. Delta P we know from equation 1, 4 to 13. So finally FR is how much? The lifting force, the resultant pressure force acting on the roof going to be equal to delta P is 45 into 13 into 100. 45 into 13 into 100. Delta P is 45 into 13 into 100. Then what is the answer? This answer how much? So when you simplify, what should be the answer? We simplify, what should be the answer? Someone tell me. If we simplify, what should be the answer? If we simplify, what should be the answer? Second one. The answer will be then, I consider second one 5.85 into the power 4. I think when you simplify it, 5.85 into the power 4 Newton. 5.85 into 10 to the power 4 Newton something. Nice question. Nice question. Then how many questions to be done discussed? Then 24. 2022 A level. 2022 A level. Right? Last few stories. Uh, 2022 A levels. Are these questions difficult? They are not difficult. If you practice TUT questions and same thing, right? They can't ask beyond the theories, right? So there is a maximum limit of asking new questions, because they have to repeat the same story, same concept, even they change the scenario. But the ideology in the question is same story. If you practiced many questions, when you go to the exam and when you're trying a exam question, that's not going to be a new question. That's the same question. Only the background is different. Therefore, practice more questions. Figure shows a siphon which is filled with a liquid. The respective heights are marked in the figure. What is the speed v of the emerging liquid from the siphon at C? Where is C? We want to find the speed of the liquid leaving from NC. Assume that the cross-sectional area of the liquid container is large. compared to the cross-sectional area of the tube, and the flow is steady and non-viscous. Again, same story. You want to apply. You want to select a streamline, and should select 2 points in the streamline. Should apply Bernoulli's equation. We don't have other ways to do this question. If I have this story, this story, this story, and there's a siphon. Having same cross-sectional area. This is point C. There's a liquid inside this container. There's a liquid inside this container. Right. Just think that now that liquid is flowing through this tube. In that case, same story. Now the important thing is the most difficult thing in this type of question is deciding the 2 points. The dividing, definitely all of you will understand. Yes, definitely I want to apply Bernoulli's equation, and anyone can select a streamline. The problem is what are the 2 points that I'm going to consider? Which 2 points, if I consider, will I get the answer? That is the problem. Since definitely you are streamline. Look here, the streamline going to be like this. Leaving this way, my streamline. I'm going to select this is my streamline. The streamline. Okay, right? The red color one is my streamline. Exactly, I'm going to consider this point Cn, a point on the free liquid surface, as my 2 points to apply Bernoulli's equation. Okay? Okay, right? Yeah. Then they have given these heights h1, h2, h3. They have given these heights. This height is h1. Look here, this height given as h1. This height is h1. This height h2, and then this height is h3. This gap is h3. Okay, this gap is h1. This gap is going to be h2 from the free liquid surface to the opening of this tube. This gap is h2. From that gap to this tube gap, the gap is h3. Now this point is point C. Let's say this point as point capital E. This point is a point capital E. Then we know point capital E is open to the atmosphere. Then the pressure at point capital E is going to be atmospheric pressure. Since this cross-sectional area of the tube is, since this free liquid surface is large, we can assume that velocity of the fluid particles at the free liquid surface is 0. Velocity of the fluid particles at the free liquid surface is 0. Then okay, V0, then this story okay. Here also, point capital C is open to atmosphere. Pressure at point capital C is going to be atmospheric pressure. Okay. but this point capital C has a velocity. That's what I want to find, I think, in the question. In the question, I want to find the velocity V. What can we do then? I want to consider the horizontal level. I consider this level as my zero potential level. It's up to you. You can consider this level as your zero potential level. If not, I can consider this level as my zero potential level. It's up to you. It's my zero potential level. It's at Pn. Zero potential level. Now apply for point capital A and point capital C. Apply Bernoulli's equation. Then you will get the answer. If you apply point capital A and point capital C, if you apply point capital A and point capital C, if you apply point capital A and point capital C, then you will get the answer. Bernoulli. Bernoulli equation for point capital A and C. P1 plus half rho V1 squared plus rho GH1 must be equal to P2 plus half rho V2 squared plus rho GH2. Then point capital A, that's my point 1. Pressure at point capital is pi, atmospheric pressure, pi, plus we know velocity of the fluid particles at point capital is 0. Therefore, V1 is 0. Half rho V1 squared term going to be 0. Half rho V1 squared term going to be 0. Plus rho means density of the fluid. How they given the density? In the question, they have given the density of the fluid as how much? Density given as they haven't given. So therefore, just consider rho G. What is H1? From the zero potential level, vertical height to this fluid, point capital E. From the zero potential level, the vertical height to point capital E going to be H3 plus H2. Am I correct? For this horizontal level, the vertical height from this level, H3 plus H2. That means H2 plus H3. That means H2 plus H3. H2 plus H3 must be equal to point capital C pressure is obviously atmospheric pressure pi, that is pi, plus half rho velocity of the fluid particles at point capital C going to be V. I want to find this V only. We know that the rho GH2, the vertical height to the point capital C from the zero potential level is 0. The vertical height to point capital C from the zero potential level is 0. Rho GH2 term going to be 0. Rho GH2 term going to be 0. That's it. That's it. Here pi cancel out. Finally, we are getting our answer. Rho cancel out. So V means V equals. You can write down V equals 2G. V equals 2G. H2 plus H3. H2 plus H3 whole root. Nice. Nice story. Nice thing. Then how many pending? We'll take a break also. How many pending to go? 24 done. Then 23 is there. 20 discussed. 22 is there. Shall we discuss 21 and we'll discuss 21, 18. We'll take the break. We'll discuss 21 and 18. We'll take the break. 21. As shown in the figure, an incompressible liquid flow steadily through a horizontal pipe. Two narrow vertical tubes are fixed at two places on the horizontal pipe where the cross-sectional area are capital A and 2 capital E. If the height difference of the liquid columns, if the height difference of the liquid columns in the two vertical tubes is simple h, height difference of the liquid columns in the two vertical tubes is simple h. Flow rate of the liquid through the pipe is, flow rate of the liquid through the pipe is, that story. 2009 A level, last few questions. Okay, last few questions. 2019 A level. Question number 21. Is it 21? It's 21. I do the diagram because diagram is important to understand some stories. The diagram. There are two vertical tubes. There are two vertical tubes. So one tube is here and the other vertical tube is somewhere here. Okay. And there's a fluid, there's a liquid, the liquid is flowing from left to the right. That liquid is flowing from left to the right or whatever. Doesn't matter even it flows from right to the left or left to the right, no issues. Now very clear, the cross-sectional area of the fluid at this region is lesser. That cross-sectional area of the fluid is given as capital A. Cross-sectional area of the fluid passing to this region is 2 capital E. This is 2 capital E. Okay. Right. Then I draw a streamline or horizontal streamline. If I draw a horizontal streamline, I consider 2 points exactly just below these two vertical tubes. This point is point capital B, this point going to be point capital C. Right? As shown in the figure, incompressible liquid flows steadily through a horizontal pipe. Two narrow vertical tubes are fixed at two places on the horizontal pipe. When the cross-sectional areas are A and 2B, if the height difference of the liquid columns in the height difference of the liquid columns in the two vertical tubes is simple h. Simple h. Now, remember, due to the speed that this liquid is flowing through this tube, due to the speed, due to the pressure of the liquid flowing through this tube, what happens? Some amount of liquid has risen through these tubes also. When the liquid is passing through this tube, due to the high pressure, what will happen? Some amount of liquid has risen through these two vertical tubes as well. What they have mentioned, the vertical height difference of the liquid in these two vertical tubes. The height difference in the liquid in these two vertical tubes is simple. That is the important thing. This question is very simple. The only news stories when the liquid is flowing through this larger tube, horizontal tube, because of the pressure, some amount of liquid has risen through both the vertical tubes. The height difference of the liquid in the vertical tubes is simple. So that is a different story. If you understood that idea, if you apply to the equation, problem solved. Now then, I'm not marking the vertical heights of the liquid. First of all, we'll apply Bernoulli logic and we'll try to understand which point has the larger pressure. Based on that, I draw the vertical heights also. Right. Okay. Okay. Right. Okay. Okay. We know that point capital B has a smaller cross-sectional area. Point capital C has a larger cross-sectional area. B to C. We know B to C. cross-sectional area increased. Larger cross-sectional area means we all know that. What can you say about the velocity at point B and C? Smaller cross-section means larger velocity. Larger cross-section means smaller velocity. When cross-sectional area increases, velocity decreases. What will happen for the pressure? Increases. Pressure increases. Then the summary is very simple. Smaller cross-section has the larger velocity, smaller pressure. Smaller cross-section has the larger velocity, smaller pressure. Right? If the pressure at point capital B is smaller, let's say pressure at point capital B is I mark it as P1. Pressure at point capital B I mark it as P1. Pressure at point capital C I mark it as P2. We notice that P1 is smaller than P2. Pressure at point capital B is smaller, P1 is smaller, pressure at point capital C is larger, P2 is larger. Remember, if the pressure is smaller, what can you say about the height to which the liquid rises through this vertical tube? If the pressure is smaller, what can you say about the height to which this liquid rises through this vertical tube? It's smaller. Because we know P equals H rho G. Am I correct? Hands up who understand that logic answer. At point capital B, since the pressure is smaller, the height to which the liquid rises through the vertical tube is also should be less. That idea genuinely understand. According to P equals H rho G, smaller height is smaller pressure. That's what we can understand. That's what we can understand. Then if I mark the height of the liquid rising in this vertical tube, I mark somewhere here. I mark somewhere here. Story is important. I have done this question in the tute questions. Just refer it. I have done these stories in the tute question. We have done. Since the pressure at point capital C is larger, P2 is larger, the height to which the liquid has risen into this vertical tube is larger. Larger. What is simple H? Simple H means the vertical height difference in the liquid in these two vertical tubes. Vertical height difference. Okay. Right. So they have given this as simple H. Now simple. Now simple. I think we learned a lots of questions. We have done lots of questions. Nicely. Nice story. Nice story, beautiful story. If you want to consider, you can consider atmospheric pressure also, but doesn't be atmospheric pressure also, but okay, no need. Okay, right. Then what is the idea? What they are asking the question actually? They are asking what? In the question they are asking what? In the question they are asking what? They are asking flow rate equation. They are asking flow rate equation. How to do this? Then we know that we want to do something with the columns. We want to do something with the now pressure P1, P2. We want to do something with the pressure P1, P2. Shall we find the pressure P1, P2 in terms of H? Look here. What shall we do? Look here. Look here. Look here. Point capital B and point capital C in the same horizontal streamline. Point capital B and C in the same horizontal level. Right? Shall we consider the vertical height to the stream? Shall we consider the vertical height to this line from the streamline? The vertical height to this line from the streamline. We'll consider it as simple x something. This gap is simple x. From the streamline, the vertical height to this horizontal line is simple x. Then tell me, what is the height of the liquid column in this tube? Simple x. What is the height of the liquid column in this vertical tube? Simple x plus simple h. Simple x plus simple h. Simple x plus simple h. Right. Then the story. Hydrostatics, we learned that hydrostatic pressure, that is equal to what? H rho g. If there is atmospheric pressure, H rho g plus phi. If there is atmospheric pressure, H rho g plus phi. So what we can do? We can write on P1 as what? P1 means pressure at point capital B means that is equal to what? X height is the vertical height to the free liquid surface from the point B is simple x. X density of the liquid, I have no idea. Rho G plus atmospheric pressure maybe pi. Likewise, P2. P2 means pressure at point capital C. The vertical height to the free liquid surface from the point capital C. P2 means X plus H. Look here. X plus H. X plus H. X plus H. Rho G plus pi. Okay. Okay, I have done something like this. I wrote like this, but I have no idea what to be done thereafter. I also have no idea what can we do thereafter. Actually, I also have no idea what can we do thereafter. Now, what have they given? Cross-section area is given, two heights, flow rate of the liquid through the pipe is flow rate. Now, I want to find flow rate. Now, we know the story. Flow rate. We know at any point, it doesn't matter cross-section area decreases or increases, doesn't matter that any point in the fluid flow, we know that flow rate is a constant. Just now we learn these stories. We know flow rate Q dot is constant. I want to find Q dot, we know Q dot is a constant. And we know flow rate means what? A cross-sectional area into velocity. Flow rate means what? Cross-sectional area velocity. Now given data, okay, we'll try to solve something. I think we might have to apply Boyle's equation also. Right. Okay. Right, okay. Now what can I do now? I found P1, P2 in terms of X and H something. I want to find the flow rate. Flow rate means cross-sectional area into the velocity. What can I do now? I want to consider B and C, and the only option is we want to apply Bernoulli. Otherwise, we have no idea. I'm applying Bernoulli also. Let's see. 4 point capital B and C, apply Bernoulli. B and C, let's apply Bernoulli. I think I explained all the questions properly. Yeah? Bernoulli. Bernoulli equation. 4 point capital B and C. Point capital B and C. Then P1 plus half rho V1 square plus. Now I'm annoying of writing this equation again. P1 plus half rho V1 square plus rho G H1 must be equal to P2 plus half rho V2 square plus rho GH2. Rho GH2. Writing this equation again, it's annoying now. Rho GH2. Rho GH2. Okay. Okay. Nice. Then we know that since point capital B and C are in the same horizontal level, if you consider this level as zero potential level, if you consider this horizontal level as your zero potential level, you can remove rho GH1, rho GH2 terms, you can remove it. You can remove it. Rho GH1, rho GH2 terms, we can remove it 0, 0. What else? Then pressure at point B, that is P1, X rho G plus pi. Now you can do this short away, but I am following all the steps. X rho G plus pi plus half rho velocity at point capital B. Half rho velocity at point capital B. I say V1 velocity at point capital B, V1 squared must be equal to, look here, must be equal to, right. Can do. My target is finding V1, then I can find the answer. Now P2 means what? X, look here, I'm expanding the bracket. This rho G is common for X and HD. So therefore I can write down this rho G is common for X and HD. So therefore X rho G plus H rho G. If I expand this bracket, X rho G plus H rho G plus pi half rho, look here, half rho, look here, half rho V2 squared. I can write V2 squared. Look here, what I'm going to do is I'm going to apply continuity equation. Q1 continuity equation. A1 V1 equals continuity story. Look here, for B and C points, look here, if I apply continuity equation story. Only two equations we are applying is Bernoullian continuity equation. Continuity equation. A1 V1 equals A to V2. A1 V1 equals A to V2. Right? A1 V1 cross-sectional area and velocity equals A to V2. Then here cross-sectional area is capital A, velocity is V1. Here A velocity is V1 means V1. Here cross-sectional area is 2 capital A. 2 capital A, velocity is v2. I thought of writing v2 in terms of v1. I thought of writing v2 in terms of v1. I thought of writing v2 in terms of v1. Subject v2. If you subject v2, yeah, v2 going to be a cancel out, v2 going to be v1 over 2. v2 going to be v1 over 2. Right? So normally we are applying the equation now. Sometimes now see in this equation there is v1, v2 terms. If you want to write v2 or v1 in terms of other, if you want to write down v2 in terms of v1, if you want to write down v1 in terms of v2, in that case only we are applying current equation. Story we have done these stories. Then half row, then v2 square. v2 square means v1 square over 4. v1 square over 4. Hands up to here everything is very clear. Up to here everything is very clear. Story is very clear. Story is very clear. Story is clear. Story is clear. Story is clear. Then what can I do now? Now I want to find the flow rate, cross-sectional area into velocity is the flow rate. Okay, x rho g pi cancel out, x rho g pi cancel out. Then what we can do here, if you bring this half rho v1 squared over 4 to the left, what you can do, you can take a common factor half. Now this row term also cancel out. Remember this row terms cancel out, row cancel out. If you take half v1 squared as your common factor out, 1 minus half v1 squared common factor out, then only 1 over 4. 1 minus 1 over 4 must be equal to hg. hg. Right. So then here, if you simplify further, 3 over 4, 1 minus 1 over 4 means 3 over 4. Right. 3 over 4 into half. Okay, half v1 square into 3 over 4 must be equal to hg. We simplified, we are getting 8 hg over 3 something. We are getting something v1 as what? We are getting v1 as what? v1 as 8 hg over 3 root something. We are getting v1 as what? 8 hg over 3 root something. I think this question is wrong. Look here. This question is wrong. The reason is what? Why it's wrong? The reason? The reason is okay, no. Correct. Because they have given any. Right, okay. Finally, hands up to now the way now. Still we have to do few more parts. Up to now, everything I explained is very clear and sub. Everything I explained is very clear and sub. It's very clear. All stories I explained is very clear and sub. It's very clear and sub. Very clear and sub. Very clear and sub. Very clear. Very clear. Now I want to find the volume flow rate. But I found the velocity at the point B, that is 8 hg over 3. I can find the answer thereafter. Easy. Now we know that volume flow rate at point B means, volume flow rate means we know that cross-sectional area and velocity. See this question, all the theory in fluid dynamics included Bernoulli's equation, Kelvin equation, volume flow equation. And this how we link the hydrostatic pressure H2 story also in this question. So from this question, we revised everything. It's a nice question. Nice question. Finally we can write down. Finally we can run see. I want to find the volume flow rate. We know at any point the fluid flow, volume flow rate is a constant. When you consider any point of fluid flow, volume flow rate is a constant. I thought of finding volume flow rate at point capital B. So therefore we know volume flow rate means we know that cross-sectional area into velocity. Volume flow rate equals cross-sectional area into velocity. Then cross-sectional area at point capital B is capital A. Velocity going to be V1. V1 is what? 8 hg over 3 root. Now look here. I can do small modifications. 8 hg means we know that it's 4 into 2 4 into 2 hg over 3 root. Correct me? 4 into 2 means 8. What can I do if I take the root of 4? What is the root of 4? It's 2. 2 hg over 3. Correct me? If you separate this root 4 and the remaining part, root 4 means how much? Root 4 means just 2. Then the root 2 hg over 3. Then A into velocity is 2 root 2GH over 3. Answer is 2A 2GH over 3 something. Any answer like that? Any answer? 2A 2GH over 3 root something. Yes, that's an answer. Fifth one. Fifth one is the answer. And time is almost at 55. We'll do one last question, 18. I'll do one last question now. We'll do the break. We'll do the break now. Hands up. We start at 7 o'clock. We'll do the break and we'll come. Hands up. We'll do 18 and we'll do the break now. Hands up. We'll do the break now. So we'll do the break now. Hands up. We'll do 18 and we'll do the break. Hands up. We'll do 18 and we'll do the break. We'll do 18 and we'll do the break. We'll do 18 and we'll do the break. Hands up. So we'll do 18. Then we'll do the break. Hands up. 18 and take the break. Okay, great. 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 Okay. Then that question also we'll discuss. Then we'll see. Now, remember now, same story is repeating and again now, right? How many questions we have discussed fluid dynamics? Same story is repeating. Same story repeating. Now, if we can do this properly, really good. 18, 2007-11 story. A pipeline laid horizontally. Now, there is an important theory to learn. Important story to understand. Okay, nice question. This one also. A pipeline laid horizontally carries a liquid of density simple D at a constant speed V from a pressurized large overhead tank. Pipeline passes through a shallow region of muddy water as shown in the figure. Muddy water. Pipeline passes through a shallow region of muddy water as shown in the figure. Pressure above the liquid surface is pressure above the liquid surface in the overhead tank is capital P and the atmospheric pressure is capital P naught. Right? Suppose a small crack has been developed on the pipe at X. Where's my X? The condition for the muddy water to seep into the pipe is seep into the pipe is seep means I think get into the pipe. Why English is so much difficult rather than telling it get into the pipe? Why they're telling seep into the pipe? Assume that the liquid level in the tank is maintained at a constant height simply from the ground and the seeping of muddy water does not change the speed V. Simple story. Sometimes when the diagram seems like very complex, remember it's not a complex story, very simple story. Story 18. After this question, we take a small break and come. Then fluid dynamics last two, then it's finished. Circular motion, we have pending some questions. That is also finished. Then we'll go back to that Newton laws and momentum. We have pending some questions. Then these days we'll plan that and finish that also. Then unit 3 possible discussion onwards, everything going in the proper plan. Now I didn't give. I have given the books and all, past paper books and all. I have printed. I have given for the previous students. Students who enrolled for previous months, I have given the past paper books and all. These MCQs and all I have printed and gave as a tute for the people. Right? But upcoming days, monthly what I'm going to discuss, I only print monthly wise past paper book separately. Okay, that's good, that's better. Then every month you will get a kind of tute pack also. The last story, then we'll take the break. Last story, we'll take the break. Normally, this past paper time duration will increase in upcoming days. Okay. Sometimes we do 3 hours. Normally we are doing 3 hours. Today we are doing 3 hours. But upcoming days, based on the time we have available, we are increasing to 3.5 hour, maximum 4 hour. Pass the discussion. Right? It's up to you. It's not I can't tell. Theory class, a compulsory class. Paper writing, paper discussion compulsory. Past paper discussion is obviously compulsory class, but I can't force them to join. But since it's my plan, I am doing that. Right? Okay. Right. Okay. I wanted to talk some stories and okay. If I do the diagram 2017-11 diagram 2017-11 So once again, one last time, what you do entire fluid dynamics question once again, redo it again by yourself once again. Then only you get the real benefit of these discussions. Sometimes when you listen to what I'm explaining, you feel like you understand. Really remember, you didn't understand what I explained everything up to now. That's a real story. You feel like you understood? No, you didn't understand. So when the cricketers, when they play cricket, we feel like, not that player is not doing anything right. Just he is what turning the bat here and there. It's very simple. When someone, no, we shout, right. When we watch a film, when we watch a cricket match, we always shout, "Oh, why this guy could not even hit that ball? Oh God, this guy even could not hit this ball. Then why is playing there? If I go there, I will hit and I will hit sixes only." Sometimes when we are looking at a match, we say like that, this guy can't hit to this ball at least. Oh God, if I go there, I will smash only sixes. But when you go to the ground and under that pressure, when you play the when you play the match only, you realize that when we look at something, we feel like easy, but when you do that something, we realize that how it's difficult, right? Uh, right. So therefore, same story. When you're listening and listening for my discussions, you feel like, oh, so very simple. No, everything that I discussed is not simple. You didn't understand seriously. Once again, redo it by your cell phone. Then only you understand that things that you feel like you understood are you didn't really understand. Okay. Once again, do it. Right. Okay. Last story. We'll take the break quickly. Right. There's a tank. There's a tank. And there's a tube like this, maybe HP pressure pump liquid in HP muddy water X HPX HPX. Yeah, listen. This liquid is flowing to this tube. There's a crack at point capital X. There's a crack at point capital X. There's a crack. Okay, there's a crack at point capital X. And this horizontal tube is passing through a muddy water. So you can see muddy water. Here, there's a muddy water. Muddy water. Just think like that. It's a muddy water. Right. First of all, forget about the muddy water and like how we have done the previous questions, we'll apply Burnell stories like how the way we have done previously the previous questions. Should select a streamline. Then should select 2 points in the same streamline. So this is going to be a streamline, right? This is going to be a streamline. Okay. Even you can't see this is my streamline. At this point is going to be point capital E. But normally this is not free actually. This point capital E. This is point capital X. This is point capital X. Right. They have given data. Given data. This is height. The vertical height of the free liquid surface in the tank from this level. They have given simplage. This is given data. Right. Pressure above the free liquid surface. There may be air trapped in the free surface, but this tank is not open to atmosphere. Therefore, we can't tell pressure at point capital A is equal to atmosphere pressure. We can't see because why this free liquid surface is not open to the atmosphere. So therefore, remember, but there are some air trapped in this free region. Pressure produced by the air at point capital A going to be P. P. Pressure produced by the air at point capital A going to be P. That is we know. That is we know. Otherwise, anything given, anything given, I plate horizontally carries a liquid of density D. Density of the liquid given. Density of the liquid given as simple D. Right? What else given data? Given data. pipe laid horizontally carries a liquid density D at a constant speed V. When you consider at point capital X, speed of the liquid at point capital X V, we know the speed at point capital X. But I am not very sure what would be the speed at point capital A. That's a problem. We'll see. We'll see. Pipeline passes through a shallow region of muddy water, as shown in the figure. Pressure above the liquid surface in the overhead tank is P. Pressure above the liquid surface in the overhead tank is P. Yeah, that's what I explained already. And the atmospheric pressure is P naught. That's okay. Suppose a small crack has been developed on the pipe at X. The condition for muddy water, to seep into the pipe is, assume that the liquid level in the tank, right. Assume that the liquid level in the tank is maintained at a constant height impelled from the ground, and the seeping of muddy water does not change the speed V. Right, okay. Right, okay. Right, okay. Right, okay. Okay. Now, right. Right. Okay. Story. What can you do now? Story is finding the pressure at point capital X. Okay. I'll do the logic. Now here the only opinion is, only thing we can do is, shall we find the pressure at point capital X? Shall we find the pressure at point capital X? Narrow tube ni. Now we also, okay. Now you may be wondering how to go to that inequality. But so far very clearly, there's a large tank, and a liquid is passing through this narrow tube, velocity of the liquid at point capital X V. There's a small crack here. What I do, I consider, let's say, pressure at point capital X, I mark it as Px. Pressure at point capital X, I mark it as Px. Okay, pressure at point capital X, I mark it as Px. Shall we find this Px in terms of given data, maybe V, D, P, H something? By applying Bernoulli's equation for a point on the free liquid surface in the tank, and point capital X. We'll apply Bernoulli's equation for point capital A and X, and we'll just try to do something. Even I also have no idea how to go to the inequality. Even I also have no idea. Since they have given simple H, definitely we want to apply Bernoulli's equation. Why? Because H terms are not included in any other equation other than Bernoulli's equation. Only H terms are included in the Bernoulli's equation. Therefore, I also feel like I want to apply Bernoulli's equation for point capital A and X. So therefore, I'm also applying. I also have no idea what to be done. Seriously. Bernoulli's equation. Bernoulli's equation for point capital A and X. For point capital A and X. Again, P1 plus half rho V1 square plus rho GH1. We'll take the break after this question completes. We'll take a break. Right? We'll finish this question, we'll go. P1 plus half rho V1 square plus rho GH1 must be equal to P2 plus half rho V2 square plus rho GH2. H2 ni. Right. Now I consider this level as my zero potential level. Agree ni? Zero potential level is at PL, zero potential level. Then this is my point 1, point 2. This is my point 1. Point A going to be my point 1. Point X going to be my point 2. Point X going to be my point 2. Then you know that, see, in here also I assume that, I feel like we want to assume that assumption. Comparing with this cross-sectional area, you want to assume pre-liquid surface, a larger cross-sectional area. Therefore, the velocity of the fluid particle at point capital A must be 0, approximately 0. In that case, what we can do, we can say that velocity at point capital A 0 means, as per my understanding, half rho V1 square term we can equal to 0. Okay. And then P1 means pressure at point capital A, that is equal to P. P1 is going to be equal to P plus density of the liquid is simple D G, vertical height to point capital A from the zero potential level is going to be simple H. dgh must be equal to P2 means pressure at point capital X. I marked it as Px. Pressure at point capital X, I marked it as Px. Okay. Uh, velocity of the fluid particles at point capital is going to be it's V plus half d V squared. What can I say about rho g H2 term? Since point capital X is in the same zero potential level, rho g H2 going to be zero. Okay, this is what I got. If I subject Px, I can write down something like this. If I subject Px, I can write down my Px going to be my Px equals. I think after now everything is very clear. My Px equals capital P plus dgh minus half dv square. This is very clear. Now, up to now, everything is very clear. Up to now, everything is very clear. Hands up. Stay focused. Stay focused. Up to now, everything is very clear. Hands up. Everything is very, very clear. Hands up. Everything is very clear. Hands up. Hands up. Now, requirement. Now, requirement. Now, I'm going to zoom what's happened here. I'm going to zoom here. I'm going to zoom the crack. What happened here? If I zoom the crack location. Yeah, listen. The crack location. Blue color water liquid is passing in the tube. Blue color liquid passing in the tube. And you can see a kind of crack. You can see a kind of crack here. Is the crack. Okay. Muddy water. Muddy water is above the tube. Now they mentioned pressure produced by the muddy water nearby the crack is equal to the atmospheric pressure P0. Pressure produced by the muddy water nearby the crack is the atmospheric pressure P0. Right? That means muddy water wants to get into the crack. Muddy water wants to get into the tube through the crack. So pressure produced by the muddy water is P0. That is atmospheric pressure. Now think practically. Pressure produced by the mud. I use red color arrows. Pressure produced by the muddy water at the crack, nearby the crack is, we all know that is going to be P0. But we know that. But the liquid flowing through the tube also not allowing the liquid flowing through the tube also creating kind of pressure. Right? Liquid also creating kind of pressure. Pressure produced by the liquid passing through the tube at X. That is we found Px. That is Px. Pressure produced by the liquid passing to the tube at point capital X is Px. Correct me? Any point in this cross-sectional area, pressure is Px. Just tell me the requirement. Now you tell me the requirement, tell me the inequality. In order to avoid flowing muddy water into the tube, what is the requirement in terms of pressure? If you want to avoid muddy water to flow into the tube, the requirement is pressure at point capital X must be greater than the pressure produced by the muddy water P0. The requirement, am I correct? What they are telling the question? What they are telling? They are telling what? They are saying that seeping muddy water does not, they are telling condition for the muddy water to seep into the pipe. Something opposite I told you. The condition for the muddy water to seep into the pipe. I told something opposite to that. Now, if muddy water wants to come into the pipe means the requirement is what? Pressure produced by the muddy water P0 must be larger than the pressure produced by the liquid flowing in the tube Px. P0 must be larger than Px. Then only the muddy water can overcome the pressure produced by the blue color liquid and muddy water come into the liquid. That logic, hands up, clear hands up. The logic, P0 larger than Px, hands up. P0 larger than Px, hands up. Hands up. Hands up. Okay, we are going with that story. There's a condition, write down. in order to flow muddy water into the tube, then P naught must be greater than Px. If I'm wrong, tell me. When Px means here I wrote something, that means P naught greater than Px I wrote as P plus, I'm writing here. Px means what? Px means capital P plus dgh, dgh minus half dv squared, half dv squared. And now you want to modify this equation according to given inequality. Modify this inequality according to given inequality. Now they are telling what? What is the what we can do here? Any answer? Any similar nice story? Uh, uh, P P not larger. P not larger. P plus HTG. Is it third one? What is the answer? Tell me the answer. What is the answer? What is the answer? Third one, right? What is the answer? Third one answer. Answer is third one answer. Answer is third one answer. Answer is third one answer. Answer. Third one answer. Third one. Third one, right? Something opposite is third one, right? Okay. Nice story. We'll take a break. Up to now, everything is crystal clear answer. Crystal clear answer. Everything we discussed today. Everything we discussed today. Crystal clear answer. Everything we discussed today. Crystal clear answer. Clear. Clear. Once again redo it. We'll take a break. Time is 9:20. I think we have normally we do take a break. I think normally after doing a 2 hour session, but today we have continuously we have done for more than 2 hours and 15 minutes. Uh, but today we'll take a break and we'll come back again because past every discussion is also parallel. We want to do it because we are in a kind of name process name, right? If we can spend more time these days when exam come closer, we don't want to spend more time for the past papers. I don't want to discuss past papers. So in that case, we can do something big when the exam comes closer, right? So okay, time is nine. Time is 9:17, 9:27, 9. We'll come back again at 9:30 something. We'll come back again at 9:30 something. We'll do the remaining two and we'll start discussing that circular motion pending MCQs. We'll go to Newton stories. 9:30. Come back. 9:30, maybe 9:32 also. I might, if I might come at 9:32 also. Maybe. Yes, ne. Right. Okay. Ne. Another 5 minutes. I've gone down. Right. Okay. Right. Okay. And shall we take 2 minutes? Is it okay? The time we'll take 2 minutes and 9:40 we'll discuss. Okay. You just close your eyes and you guys sleep. 9:40 we'll discuss. Okay. Just take us 2 minutes small sleep. Yes. Okay. Right. Right. Okay. Okay. Then next two questions, last two questions in fluid dynamics. Also, we finished all the MCQs. Then we can do Tata bye bye for fluid dynamics questions also. Right, last two questions. 2020 A level question is really a bit complex question. It's a really bit complex question. We'll try to solve that question. We'll try to solve that question. As shown in the figure, 2000, I think 20 level. As shown in the figure, a horizontal pipe ABC is connected to a water tank with a large cross-sectional area. The internal cross-sectional area of the pipe at capital B is twice that of C. The internal cross-sectional area of the pipe at B is twice that of C. Initially, a water tap capital T located at capital D is closed. Once the tap is opened, what would be the height of the water level in the vertical tube? What would be the height of the water level in the vertical tube located at B? Located at B. Assume that the water flow is steady and streamlined, neglect something, something. Now I do the diagram. This is a nice question. Seriously, a real nice question. Seriously, it's a nice question. This is also a nice question. The question that we are discussing now was a nice question. 2020 level, right? Okay. Stay focused. 9:43. I think this time today we took a 20-minute break. It's okay. It's okay. It's okay. Right. Okay. 2020 level. I do the diagram as well. The careful listen. Now this is like an essay question. 2020 level. I do the diagram. There is a very large tank. It's a very huge tank and a pipeline. Uh, right. This story and water. When I consider, I draw a horizontal streamline for our understanding. I draw a horizontal streamline. Look at the streamline. My streamline is red color. The liquid surface, the tank is at this level, right? Okay. And there's a vertical tube also. Ne? There's a vertical tube also. There is a vertical tube also. So you also, when you are writing these stories, you also should draw the diagrams. Some students, they don't do the diagrams because they are lazy. Okay. You guys should draw the diagrams. Should draw. It's must. I consider streamline. This is going to be a streamline. This is going to be my streamline. Okay. Listen very carefully. It's a nice question. You can learn a lot. You can learn a lot. You can learn a lot. And liquid is flowing through this tube, right? Liquid is flowing through the tube. Red color one is a streamline. And when the liquid is flowing through the tube, due to the pressure at this region, the liquid will be rise in a height, maybe h dash. This liquid has rise in a height in this vertical tube, maybe up to height h dash something. I have no idea what height exactly. I want to find that height only in the question. The question also, I want to find that height only. Right. So then point capital A is somewhere here. Here is point capital A. Where is point capital E? Point capital B is somewhere here. Point capital C going to be, this is open to atmosphere. This is open to atmosphere. This point capital C. Right. So then the velocity of the liquid, have they given it's what? Have they given it's water? No. It's water. So velocity of the water leaving at point capital C going to be capital V something. Velocity of the liquid leaving from point capital C going to be capital V something. Capital V. So now when you read the question, you understand that the cross-sectional area at point capital B, the cross-sectional area in the region B is twice that of cross-sectional area in the region A. If you say cross-sectional area in the region A is, let's say capital A, the cross-sectional area in the region B going to be 2 capital A. The cross-sectional area in the region capital B going to be 2 capital A. This story. Yes. Okay. So far, understandable everything. The vertical height to the free liquid surface in the tank from this streamline is simple H. Is also okay. Then we understand that if we consider a point on the free liquid surface, At that point, I consider as point capital D. Point capital D is given. At this point, I consider as point capital D. Then what can I do? On the streamline, if you select 2 points, one is point capital E, other one is going to be point capital C. So what is the pressure at point capital E? Since this free liquid surface of the tank is open to the atmosphere, pressure at point capital E going to be the atmospheric pressure. Pressure at point capital E going to be the atmospheric pressure pi. Pi. So then we'll consider point E and C. And first of all, shall we apply the Bernoulli? Still, I have no idea how to get the answer. Shall we find the Bernoulli? If you apply Bernoulli, we'll find something. Apply Bernoulli, we'll try to find something. Apply Bernoulli, we'll try to find something. Right? Okay. Bernoulli for point E and C. Bernoulli. Point E and C. Do I want to write this entire equation? Okay, write down. It's okay. Don't become lazy, Suleiman. You should be, right, very active. Half rho V1 square. Don't be lazy, Suleiman. Should be very active. Rho G H1 must be equal to P2 plus half rho V2 square plus rho G H2. Okay. Point 1 going to be, let's say, this point E. Then pressure is atmospheric pressure. It's pi. Same story. When you consider since the larger tank, the free liquid surface cross-section area is larger cross-section area, velocity is very smaller. We can assume velocity of the fluid particles, velocity of the water particles at point capital E, free liquid surface water particles has zero velocity. In that case, half rho V1 square term going to be 0. This term going to be 0, right? Okay. Then rho G H1. If this level is 0 potential level, ZPL, vertical height to the point capital E from the ZPL is simple H. Then density of the, have they given the density? Density is I marked as rho plus rho GH. Rho GH must be equal to pressure at point capital C. Point capital C, when the water is leaving at this free end, point capital C also open to atmosphere, pressure at point capital C is going to be pi. It's pi. It's pi, right? Correct me? It's pi. Then pi. Then plus half rho velocity at point capital C I marked as capital V. Velocity at point capital C I marked as capital V. Let's say V. Let's say V squared. Rho G H2 term going to be 0, because this point capital C is at the 0 potential level. Therefore, potential energy per unit volume term is 0. Rho G H2 term going to be 0. This story is done. Now they are asking something else. Actually, they are asking this height, I think. They are asking this H dash something. But I am doing something else for a reason. Let's see. Right, next time again I'm going to apply. Now see, this question is somewhat different. All the previous MCQs, we only apply Bernoulli's equation one time. Right, this is something different. Because we are going to apply Bernoulli's equation 2 times for the story. Already applied Bernoulli's equation for point E and C, and I'm getting something. From that something, I'm going to get another something. That from the another something only, I'm going to get this H dash. You will understand the story. The previous questions, we applied Bernoulli's equation only one time for 2 points. Only one time. But here, now we are applying Bernoulli's equation for E and C. Again, I will apply, you will understand. Again, I will apply Bernoulli's equation. Okay, right. Pi cancel out. Pi cancel out. Rho cancel out. Then I can write down V means velocity of the water at point capital C going to be root 2gh. Capital V going to be root 2gh. That is very clear. Velocity going to be root 2gh. 2gh root. This story is okay. Now the problem is, my target is I want to find the H dash. We know that since this vertical tube is open to the atmosphere, there is atmospheric pressure also acting on this free liquid surface. Okay, my target is finding H dash. then we know that I want to again I want to apply Bayes equation for point capital B and CEO EO something. Right? The problem is, okay, when you consider this tube also at point capital C also, cross sectional area of the tube is capital A. Look at what I'm doing. When you consider this tube also, cross sectional area of the tube is capital A. But we understand that this point B, that region's cross sectional area is 2 capital A. So I know at point capital C cross sectional area is capital A, capital A. I know the velocity at point capital C is root 2 GH. What I thought of doing is, I thought of considering B and C n. I thought of applying continuity equation. Why? Why? Why I am doing that? Look here. Look here. Look here. Story. Right. I will explain. Okay. See the story. After everything is very clear and up. On the story is very clear and up. Story. What I have done so far. What I have done so far is very clear and up. Very clear. Very clear and up. Very clear and up. Now, what's our target? Tell me, okay. Tell me now, what's my target? My target is H dash, right? Now, anyone understand that? Sir, our target is H dash, right? Since our target is H dash, they're asking vertical, open, what would be the height of the water level? They're asking us to find the H dash. Sir, what I feel is, previous question, you have done something, not this one. Previous question, we have done that, sir. H dash, we link with hydrostatic pressure, H rho G equation all. That means we have done pressure at point capital B. We can write it as H dash rho G plus pi, right? Right. That's what we all can think. All right. Then pressure at point capital B, I don't know. Pressure at point capital, I don't know. Right. So, but I can write down pressure at point capital B as what? Pressure at point capital B means told us H rho G equation. Pressure at point capital B means H dash. That's what I want to find. H dash. That's what I want to find. The density of the water is rho. Density of the water is rho. G plus atmospheric pressure is pi. Right. The problem then, what can I do? Now this one, anyone can. Now when you look at the equation, if you want to find H dash, anyone will think this idea, because point capital B pressure means H dash rho G plus pi. But they don't know how to get this H dash value. They don't know the steps. So then one can think, after that, one can think, okay, I know point capital B pressure. I linked pressure at point capital B in terms of H dash. So I can apply Bayes equation for 2 points. One is definitely point B. I'm going to apply Bayes equation for 2 points in the same streamline, but 1 point must be point B, because I want to involve H dash, right? So therefore, 1 point is point B, other point can be point C. If not, your other point can be point E also. It's up to you, right? Then I'm applying point B and point C Bayes equation. Point B and point C, I'm applying Bayes equation. The way you're thinking, right? So if I apply Bernoulli for point B and C. Nice question. Put a superstar, point B and C. So if I apply Bayes equation for point B and C, sir, look here. Pressure at point B. So pressure at point B. So pressure at point B means so what? H dash rho G. Now see. Okay, I'm writing the. Oh, I'm lazy. Lazy, right? P1 plus half rho V1 squared plus rho G H1 must be equal to. At least you guys still don't need to write these things. Tell me, will you? You guys also not telling me. Half rho V2 square plus rho G H2, right? Time is 10 o'clock. Oh God. Then P1 means pressure at point B. So just now we got pressure at point B as H dash. So H dash. Rho G. H dash rho G plus pi, sir. Okay, plus half rho V1 squared. What is V1? Velocity at point capital B. Velocity at point capital B, I mark it as VB. Half rho V1 means velocity of the water at point capital B, I don't know. Velocity of the water at point capital B, I don't know actually. I don't know. Point capital B, point capital C in the same horizontal level, zero potential level. Rho G H1 term is zero, rho G H2 term is zero. Then must be equal to pressure at point C means pi this story. Velocity at point C means half rho. See, half rho. Velocity at point C, just now I found. Velocity at point C, just now I found how much? Root 2gh. Velocity at point C means how much? Root 2gh. V square means 2gh. 2gh. I think you all understood this story also. Because now see how I could substitute this 2gh value. How did I substitute this 2gh for velocity at point C? Because I found velocity at point C by applying Bernoulli's equation for E and C. So one time I applied Bernoulli and I found the velocity at point C. Again I applied Bernoulli's velocity at point B and C. Then I substitute here. Still my target is find H dash. My target is find H dash. But still I can't find H dash. Why? Because I don't know VB. This rho terms, if pi cancel out. Pi cancel out. Rho terms cancel out. Rho terms cancel out. But the problem is still I don't know VB. See, thereafter what I am getting is C here. H dash equals C here story. See here, nice question. Nice question. Once again do it. Once again do it. H dash. H dash in G H dash plus VB squared over 2. I don't know VB. That's the problem. I don't know VB. That's the problem. VB squared over 2. If I know VB, problem solved. Must be equal to 2 to cancel out GH. GH ni. I'm getting something. Somewhat simplified. Somewhat simplified. I want to find H dash. I don't know VB. I don't know VB. What can I do? What can I do now? Any idea? Any idea from your side? Tell me just from your ideas. Just put some chat. Right now, 2 times. The first time in all our previous MCQs, first time only we applied Bernoulli equation 2 times in an MCQ. Right, and I have done something, and I came here. I got stuck. I want to find H dash. The problem is I don't know VB. I got stuck because I don't know VB. Any idea? Any idea how? Tell me your idea. Tell me your idea. What can you do now? What can you do now? What can you do? Sir, what can you do is one total idea. One total idea. What about you guys' idea? Tell me. Put some replies. Put some replies, everyone. We got stuck. But we know velocity at point C, remember? We know, now see the given data. Now see, we haven't used 2 capital A story also yet. We know velocity at point C also, right? I got stuck at VB. Tell me what we can do. Just put some replies quickly. No time. 10 o'clock. Put some replies. Waiting for some replies. Waiting for some replies. Quickly. Anyone? Guys, you are there at least. Apply continuity equation to find VB. Yes. For point capital and B and C, sir, will apply a continuity equation, sir. So B and C, for point B and C will apply continuity equation. See how this question is complex. Really complex question. If they have given a question for this MC, this is the normal last question only they are asking. It's a difficult one. But difficult, ni? If they ask this question in MCQ, better to avoid doing this question and do the remaining. Right? Even though it's a fluid dynamics question, don't do this question. So how many simplifications are there? Apply continuity equation for point capital B and C. But this past paper discussions really gives a good exposure for you today. All the methods and stories. I am taking time and I'm not. I'm really reviewing these questions. I am not getting the answers. I'm reviewing. I'm giving a theory idea. I'm going to theory stories and I'm reviewing these stories. So review of past paper review. So you don't need to look at the past paper reviews. So I'm the one who is reviewing everything. Much effective way. Cross-sectional area at point B is 2 capital E. Velocity at point capital B going to be VB. I want to find VB only. Then cross-section area at point capital C going to be capital A. Velocity at point, sorry, C will be root 2gh. That's it. A cancel out. Finally, your VB means what? Finally, your VB going to be, finally, your VB going to be root 2gh over 2. Root 2gh over 2. Root 2gh over 2. Root 2gh over 2. See, you can't see any 2gh over 2. Huh? Finally done. Done, sir. Now I think, sir, I can get the answer, sir. I'm really, really closer to the answer. Let's see whether I can get the answer. GH dash, sir. Nice question. Very complex question, I agree. But nice question. So VB means, just now I found, VB means root 2 GH over 2. VB squared means, now here half into, so VB squared means root 2 GH over 2 squared means 2 GH over 4. Just do it, huh? Every step can't explain 2 GH over 4. If I'm wrong, tell me. 2 GH over 4, sir. 2 GH over 4, sir. Must be equal to GH, sir. Must be equal to GH. Yes. Done, done, done. All the G terms cancel out. 2 cancel out. I think in that case we are getting, if I'm wrong, tell me, H minus H over 4 something as or H dash. Is it correct? If I did I do any mistake, tell me. Huh? Then 3H over 4 seem like our answer. 3H over 4 seem like our answer. 3H over 4 seem like our answer. Have we done any mistake? Correct, me? It's correct, right? Hands up, it's correct answer. How many say it's correct answer? How many say it's correct answer? It's correct, ne? 3H over 4. It's correct, ne? Nice story. Nice question. Nice question. Nice question. The last fluid dynamics question. Then I complete that section also. The last fluid dynamics question. Please read once again. The last story. The diagram is not clear. That's the problem. Where is X, Y, Z? I can't see this in this Spicer book. Can someone share a proper picture of it? Right? Because this question number, the last one is 19. 2018 level question. Fluid dynamics. But I don't have a proper picture. Maybe this will be the last question for the today's session. Maybe plan to circular motion also 3 hours done. Okay. Can someone send me a proper picture? Can someone send me a proper picture if you can? Can someone send a proper picture? Then we can discuss the last one also and we can finish the fluid dynamics chapter. So then again, we are not discussing fluid dynamics. In past papers, I think I have done all the past papers also. Past essay question also, I have discussed all the fluid dynamics. The last question, today's last question, someone share a proper PDF, proper question. Pranali, can someone send? Pranali or someone? If not Amaya, can you send someone? Not Akshadao, I don't know someone. Rifana, someone, I don't know. Last one. Waiting for someone to share the, waiting for someone, waiting, someone will share it. Anyone sharing, hands up. If others I don't know, ne? Quickly. Hands up, who's sharing, hands up. So I'm searching, I'm sharing, hands up. I'm searching, I'm sharing. No one. You. Right, okay. Bahashi sent. Thank you. Thank you, Bahashi. You are a gem. Am I also shared? Same time. Good timing. Ah, okay. XY. Okay, that's it. The last one, 2018 last one. Story finish. Look here. The last story. Then we can have a nice sleep. Today is circular motion. Want to do? Roughly 3 hours we are done. Roughly 3 hours. 10, 15 only we are finishing. The last story. So likewise, every section, if we can finish like this, definitely we can getting bees like a eating a chocolate. Getting bee, huh? Getting B is like eating chocolate. If you do like this, getting A is like eating a bubble gum. If we do this properly, that's the problem. Because when there's a support from students and only I get motivated. If I see no any support from any batch, I get demotivated. And I think what is the purpose of doing these things? These are additional things. Pass discussion is something additional. I can do one class. I can do one class for the money that I take. I can do one class. 2 hours, maximum 2.5 hours is enough. And I can put some mixed questions. I can give a paper and I can discuss next day. First week writing, next week discussion. Likewise, I can do a session, but I'm not doing that. Expecting something. Students also really supporting me, and then definitely I will work more. No, that's my way. If you give support, I really work more. If I feel no support, nothing there, then I don't work. That's obviously these things are something additional thing that I'm doing. Okay. Right, okay, last one. Stop talking the gossips. 2018 level, then we can finish it and we can go and have a sleep. 2018 level story. Here, look here. Give me 1 second. Okay, the question. It says that consider a non-viscous incompressible fluid moving with a steady streamlined flow through a tube of non-uniform cross-sectional area in a vertical plane. Vertical plane, huh? This tube is vertical tube. This tube is in a vertical plane. Now that cross-section they have considered is a vertical cross-section. This tube is like this. This type of tube. Okay, they have considered cross-section. The cross-section area varies. Okay, know that. Figure shows the vertical cross-section of the tube X, Y, Z represent the three portions of a streamline. Area of cross-sections of tube at X is same as at Z. Noted. Look at the diagram. If I do the diagram, look here. Look if I do the diagram. Look at the diagram. If I do the diagram. Where is point X? If I take a streamline. If I take a streamline. Point capital X is somewhere here. Point capital Y is at the top. And point capital Z is somewhere here. They mentioned cross-sectional area at point capital X and cross-sectional area at point capital Z, they are same. Cross-sectional area at point capital X, capital A. Cross-sectional area at point capital Z also capital E. These things are important, right? Okay. Then vertical cross-section. Then I can consider here is my ground level. This is my ground level. And I want to properly mark location of X and Z properly, because it's a problem. Here is my X. Here is my X. So then when you mark the vertical heights from the ground, if you mark the vertical heights to point capital X, Y, Z from the ground, you can understand some stories clearly. Can understand some stories, right? Okay. Okay, right. Consider the following inequalities for the relative magnitudes of kinetic energies per unit volume, potential energy per unit volume, and the fluid pressure at x, y, z respectively. Okay, right. Okay, okay, right. Okay. A statement capitally they are telling kinetic energy at z is smallest, kinetic energy at y is largest. The statement A, look here, what they have given. Statement A, they are telling kinetic energy at Z is lowest. Not kinetic energy unit volume. Kinetic energy per unit volume at X larger than kinetic energy per unit volume at Z. Largest kinetic energy per unit volume is belonging to point capital Y. Hands up, how many we say? This statement is correct answer. Raise your hands, how would we say? This statement is correct answer. Statement is correct answer. Raise your hand, someone who says statement is correct. This statement is wrong, sir. So this statement is wrong, sir. Statement is wrong, sir. Statement wrong answer. Statement wrong. Statement wrong. That's very clear. Because we know that, sir, just now we learned, sir, we learned kinetic energy per unit volume means, what is the equation? So kinetic energy per unit volume, not kinetic energy. Okay, now, yeah, I mean K means kinetic energy per unit volume. That equation is what? So half rho V square. Since same liquid and density is constant, rho constant at point capital X and point capital Y, point capital Z, rho constant. Sir, they have mentioned cross-sectional area at X and Z are same. So same cross-section means we know that, sir. Volume flow rate means cross-sectional area into velocity. Sir, in this tube, any point in the fluid flow, in this liquid flow, volume flow rate is constant, sir. Volume flow rate is constant. Remember, volume flow is a constant at any point in the flow. Then, sir, if a point capital X and point capital Y have same cross-sectional area, volume flow rate is also same at X, Y, Z. Cross-sectional is same at X and Z. So, velocity of the fluid at X and velocity of the fluid at Z must be same, sir. The velocities must be same. The velocities are same means what? Velocity at X and Z same means kinetic energy per unit volume term rho same, V same means, remember, kinetic energy per unit volume at X and kinetic energy per unit volume at Z must be equal. But here they have mentioned larger. Statement is wrong. Statement B. We'll go to the statement B. Hands up who says statement B is correct answer. Statement B correct answer. Statement B correct answer. Potential energy X smallest, Y largest, Z second largest. Hands up. Statement B is correct answer. Statement B is correct. I also agree because potential energy per unit volume means rho G H. Rho G H. Rho same, G same. Large the height, large the potential energy per unit volume term. Large height belongs to Y, then Z is second largest. Lowest height belongs to X. Statement B is correct. What about statement C? What about statement C? Statement C story. A wrong, B correct, that's obvious. Statement C story, pressure at, statement C is telling something like this. Statement C is telling pressure at Y is lesser. Pressure at Y lesser. Pressure is largest pressure is point X. Okay, Z and X. Okay, look here. Now we know Bernoulli's equation is what? At any point on the same streamline, when you consider any point the same streamline, pressure plus kinetic energy per unit volume plus potential energy per unit volume must be always a constant. When you consider any point, X or Y or Z, the summation of these three corresponding to those points must be a constant. Okay, now only we came to a conclusion. Look here. Look here. Look here. Just compare X and Z, it's easy. Just compare X and Z, it's easy. For X and Z, look here, kinetic energy is same. Agree? X and Z, same cross section, same velocity, kinetic energy is same. Just now we came to a conclusion, X and Z, Z has the larger potential, am I correct? Z has the larger potential unit volume. right? Look here, this is X, this is Z, sorry, this is Z, this is X. Pressure at X, pressure at Y, sorry, pressure at Z, kinetic energy, potential energy, constant. Remember, Z has the largest potential energy per unit volume, then X has the smaller potential energy per unit volume. Small height. Then what can you say about the pressure? Which one has a large? Because we know summation must be constant. For an example, Z's kinetic energy 500. Uh, X also have kinetic energy 500. But Z's potential energy, we know that it's larger than X potential energy. Let's say 100. Z's potential is 100. Let's say X potential is low one, 50. The summation, when you add pressure also, summation is, let's say, all summation must be always, let's say, 700 for an example. Then what is the pressure of Z? 100. What is the pressure of X? 150. 550. Then you want to understand pressure at X must be larger than pressure at Z. Pressure at X must be larger than pressure at Z. That is okay. That is given. That is okay. Pressure at X must be larger than pressure at Z. That story is okay. We'll come to this story. Let's compare Z and Y. If you compare Z and Y, look here. Y has the largest potential energy. Right? Y has the largest potential energy. Y has larger potential energy. Z have lower potential energy. Look here. Look here. Cross-sectional area at Y is lesser. Cross-sectional area compare X and Z. Cross-sectional area at Y is lesser. Lesser cross-sectional area means larger velocity. Larger velocity means larger kinetic energy at Y. When you consider Y and Z, now Z has, look here, right, look here, when you consider Y and Z. So we know that larger kinetic energy belongs to, now I have considered here for our understanding, Z has 500 kinetic energy, Z has 100 potential energy, roughly. Z has 100 potential energy, I consider Z has 100 pressure for an example. Then Y has the largest kinetic energy. That means kinetic energy is 600 something Y, for example. Okay. And Y has the largest potential energy also. The Y potential energy may be how much? 150 something. Because potential energy of Z is 100 then Y has the largest potential energy, maybe 150 something. Then what can you say about the Y's pressure? Y's pressure must be the total must be 700. I see total is kinetic. Okay, I say that a simple story now. Okay, simple story. Now see, this is the idea. Now Y is having C. When you compare with, if I do this as 800 something, 800, then you understand the idea. I will explain later. Once again, I will explain. We have time. Then this is 800 means 5, 600 is 200. It's 200. Then this one is how much? This one is for an example. 550 means 250. Is that is 200? This 200 is 150. Then the pressure at Y will be lesser, 670. So pressure at Y is lower, Z is larger. Then statement C also correct. Hands up by putting some values, and I try to show something. This is clear, hands up. This story is clear, hands up, really genuinely. What I explained is clear, hands up. It's clear, it's clear. It's clear, right? Then want to explain again? Simply kind of comparison, right? See, when you compare Z and Y, Y has larger potential energy than the Y has larger potential per unit volume than the Z. Y has the larger kinetic energy unit volume than the Z. Then pressure must be lesser in Y than Z. That is the idea. Then I think I have discussed everything, right? Okay. Okay, time is almost 10:20. Plan to do until 10:30. Right. Session is very effective, hands up. Session is very effective, hands up. Lesson is very effective and lesson is effective, right? And 25 people. Today I'm not doing the class because I want to prepare the paper tomorrow. MCQ paper 50 MCQ. Still I'm preparing. So tomorrow night 10 p.m. onwards, that paper discussion we have one essay, three, four structure. We can finish that. Four structure we don't take, and Friday full that MCQ discussion is there. Saturday, Sunday night time we'll have past paper discussion. Saturday, Sunday evening time we'll have theory class. Okay, so we'll do in that. Today I want to do a paper pass or discussion for you. Today I'm not doing because I could not prepare the paper yet. Okay, right. So then study will